Hello, testing to see if everything is working. So please let me know if the audio is good or not. And good morning. Forgot to say that first. So it's been a long time since I've done this. Let's see how it goes. I'll just wait for the confirmation that the audio is good, and then I'll start explaining what we're gonna do today. Asking our guys here internally. Let me see how I can monitor what's going on. Okay, so have good confirmation. So um, let's start. So it's been a long time since I've wanted to start coding this. Actually, a lot of ideas that we've been discussing um, over the past years. So you guys know that we have Fusion that has a super nice um, feature set for shooters like lag compensation and built-in snapshot interpolation. But the point is that Quantum is also accurate tick based, but normally you build Quantum using prediction for everything you see. And that is super interesting for the types of games that you normally build with Quantum. But what about how can we do the kind of stuff you normally need on a shooter? And I'll also explain why you need that on a shooter, which is why don't you predict everything on a shooter? Why don't you try to do something like the way Quantum works on a shooter? The answer is kind of counterintuitive, but it has to be explained. So the point is that when you use prediction for everything, um, it works really good for when you have close combat, when you have physics and all. But when you're trying to do a shooter, that's not really good, because that means that when you do raycasts or projectiles that are moving entities or something like that, they're gonna all work on the same timing, meaning that I see the prediction of other characters. I try to shoot towards that target, and let me close this thing here so I don't get the annoying audio. I'm not sure if you guys heard that. So you are trying to shoot against a moving target, and the point is that if that moving target in his own prediction is changing direction a lot, it means that when you get the confirmation of the inputs in Quantum, they would never be where you saw them, and that means that it's very easy to miss the shots. And this is whatever tech you use. If you're predicting everything, it's very difficult to shoot in 3D, especially because you need a very accurate shooting in 3D with a 6 degrees of freedom. So the reality is shooters use a bit of a cheating technique to favor the person who's shooting. So what you do is you don't predict other characters, you only predict your character. So you see everybody else in the past. And that's the whole point of snapshot interpolation. You're going to see visually the other characters really in the past. And you shoot at what you see. So then lag compensation comes into place, because if a server, let's say a Fusion server, would shoot with the raycast that you did when you saw something, the character would not be where you saw him when the data comes to the server, and the server is simulating that very tick for every single one of the characters. So you would also miss the shot. So what is lag compensation then? Basically, the client is sending to the server all the time information about what is actually the timing that the client is seeing for remote players. So I have my prediction of tick 100, but I might be seeing other characters at tick 95. So the client is constantly sending that information to the server. So the server knows, also measures the ping of the client. So it knows at which point the clients are seeing the other characters. And when you shoot and use a lag compensated raycast, when it happens on the server, what it does, it shoots not against where the characters are now, but it has a previous buffer of where the characters were, and then it shoots on the perspective of the particular client that's doing the shot. So that's favoring the shooter on that client. That's the topic of lag compensation. So what we're going to do now is we're going to implement these two things in a bespoke way on top of Quantum, but it will be as accurate and it would solve exactly the same type of problem. Um, so you can have a super accurate shooting in quantum. And then you gain all this stuff like kill cam replays and all the shebang that quantum can give you. And on top of this, of course, I'm gonna show how you can predict only the local character, but everybody else on verified frames. This also saves performance. And then I'll also show how to do a very accurate camera yaw pitch type of thing for you to send as part of the input. And we'll be doing all this on top of Quantum 3. It's actually the first time I installed Quantum 3 as a package. I work on the SDK itself, but I haven't worked a lot as building demos. This is actually my first Quantum 3 demo, so I hope we're gonna have something cool to show. So let me start sharing the actual screen here. So what we have is a brand new clean Unity project on a somehow old LTS version here. So it's a 21.3 LTS. But so let's import the latest preview package we have for Quantum 3.0, which is build 1293. So as you guys know, everybody who's been trying Quantum 3, it is just a Unity package now. So I checked this before. I would just import everything. Everything is new. This is a clean project. So let's just see what happens here. We'll do a few tests before we start coding the new stuff, actually. So just importing everything. I think it's going to open the Quantum Hub, which is similar to the Fusion Hub now. To finish the installation, let's see if this is going to be a clean one like the test one I did a few minutes ago. And okay, you guys can ask questions directly on the stream. I have the chat here. I have some of our other guys also watching. So, and of course, this video is going to be stored for later. And eventually, this that I'm coding here is going to become a text sample. So we'll share this with Circle at some point. So first install. We need to click this here, install. It should do some extra stuff that Quantum requires. Let me click this. Yep. Let's see. I think. Oh, it's have to finish this. So reloading everything. Everything for the base installation went fine. I need an app ID. I actually created an app ID for testing already, so let me just grab that app ID. Although we're not yet running online, but I'll go ahead and paste this app ID here. I'm gonna disable this app ID later. Actually, I'm gonna do this off screen, so I'm not gonna share the app ID. Sorry about that. So app IDs done. I closed that window, so let's just go ahead here. So we have the normal Quantum stuff here. I think we will have we have this new sample menu. I think we need to import TextMesh Pro because it's needed by the menu. So let's take a look at this, if this is all. I don't need examples and extras, I guess. Let's see this. I don't want to see low resolution. I want to see basic stuff. Let's see if this is looking correct. No. Okay, this was just loading some stuff. So, okay, menu looks good now. So let's see what the sample game comes with. This should run Quantum locally. So we have Quantum running here. We don't have any entities. So let's put some stuff here and let's start just placing a character controller. So here's what we're gonna start with. We're gonna start with the mouse look control so we can rotate the character, and then we'll jump straight into shooting because then we can put a moving target that we can start shooting with lag compensation. And I'll explain everything I'm doing. So let me check here. All sounds good so far, and no questions at the moment. Okay, so how am I gonna start with this? So we have the gameplay scene here. Let's start by placing a. Do we have a quantum? Oh, no, not that. Sorry. So let's start adding some quantum 3D static box collider, so we can have a floor. So I'll extend this guy. What about maybe I don't need to extend like this because I might be able to do this, and the collider is also gonna expand in this case. I think so. It does. So saving this. So I have a kind of a box to fall on top of, and I can also create. So I want to create a new prefab for our player entity. So let's see what we have here. So we have a character controller entity. I'll start with that because what does it come with? So let's take a look at it here. It's a sphere. I'm gonna modify it to be a capsule because this is something I'm gonna be doing also on the and at different points. So I'm gonna be adding a capsule. I'll modify the character controller to use a capsule. That's another task we have here, but this is not gonna interfere with what we're doing today. So um, no need to work. So what we have here, so we have a collider. You know what? I'm gonna start with the capsule entity that we have now, and I'll add the character controller to it. So I think that's gonna be easier to set up. So I'll start with a capsule entity. I'm gonna move it up a bit. Let's call this guy character. In this case, it doesn't have a separate view, which is so movements. Okay, so I'm gonna overhaul the rotation. Yeah, that's still fine. So no button. I will not bother with that. So um, it has the entity view. It has a character quantum entity prototype. Um, so what I will add here, so we have a capsule, which is fine. If I remove the renderer, I can see the capsule. I think the dimensions look okay. Then to add a character controller, I'll add it like this. I'll link the default, I'll link the sample character controller 3D to it, but I'm gonna modify a few things because I want to make the character controller fit match what the capsule collider is. So this guy is gonna walk over the floor. So this is just a collider at the moment. So if I move this guy up and I press play here, it is actually part of the simulation, but it will not fall. It's just a static collider at the moment because we don't have a system to run the character controller, and that's what we're gonna do now. So wow, this is new to me. So how can I create systems? Is there a suggestion? This is Quantum User, so can I just create a folder here myself? Systems. So perhaps then I just create, do we have a Quantum context menu here? I guess we, Quantum, does it let me create a system? Let me create a QTN file, which is cool, but we don't have one. Oh, system config, which is a new thing that we may talk about, which is, hello, to who's commenting, so thanks, Bartek. And yeah, look, I'm already on the game. Okay, so you suggested we to put it on the game folder? Oh, okay, because we have some stuff here. So we have system setup, but okay, so I'll move my system folder to here. But there is no context to create a system. I'll just create a regular C# script. Is this already yeah, it's just a regular C# script. I guess that, but so let me call this my movement system. And because this all runs from inside Unity. I have a question here for Luke or whoever else from the team. So this is actually going into an assembly definition. Um, this is going into an assembly definition automatically, and it's on the right assembly definition, I guess. So because I placed it on this folder here. Yeah. So several guys from our team made me sure that it has to be inside Quantum User Game. I guess it's that because that is the default assembly definition folder we have. So it helps putting it there. So I opened the writer here. Let me show it to you guys. Let me increase the font size a little bit. But this guy is not gonna be a movement system, so I'll keep the collections. And you know what I'm gonna use? This is Quantum. I don't need to use Unity Engine for this. I am gonna put this on namespace Quantum. And I'm gonna move this guy inside. I don't need these. I think I can then put this guy system main thread filter. I'm also gonna create a public struct. Oh, movement. No, I normally do it. My pattern is to put it inside the class. So struct filter. So I can just call it filter. We need to put here public entity ref entity. And then we put the components we need. So I want to have a transform 3D pointer, call it transform. I want to have a public character controller 3D. I'll call it KCC. That's enough for now. It's complaining because this has to be unsafe. Not that. I want to make the whole class already unsafe. No comments, so looks like we're good. Okay, so then this guy being dot filter, then I just need to implement the updates for it. I like to put the filter last. So here's our filter, and what I'm gonna do is filter dot kcc. I'll just use the standard movement. What do I need to pass to it? So I need to pass the frame. Oh, is it still called F? We shouldn't call this frame. I need to pass the filter dot entity. I need to pass what else? I think it's now the direction, if not mistaken. Yeah, I'll pass no direction for now. Callback mask. I'm not gonna pass these for now. So this shall make the character fall at least. And then we'll start implementing the input next. So because it's all Unity package, it shall be compiled already. We just need to make this system be part of our system setup. Is there a default system setup? Photon server, default configs, went to Unity DB, session config. Okay, so okay. Let me see. I know I can create a new one, but I want to check which ones are predefined here. So I'm not sure. Maybe I should just create one. Let me check if our quantum runner, quantum starter here has a reference to that. So in runtime config, yeah. In runtime config, we have the. Thanks, Jonas. I figured it would be here also. So here it is. So this is now a data-driven way for you to define systems. So so we have a culling system 2D. I'm gonna remove this guy. because I don't need it. Then I have culling system 3D. We're gonna replace the culling system as well later, but first I'm gonna introduce something here. So 3D physics, I'm gonna remove the 2D physics. No, this is an array. This is not super easy to mess around with. So navigation, entity prototype. So normally we would play a connected. We'll put stuff after all these. So let's make this 8 entries. So our element number 7 is our movement system. So saving this here should already work. Yes. Okay. So the guy is now falling, which is what I expected. So let's see if I have important comments. No. Looks good. Oh, if I create a new one, it will come with all default system. Thanks, Luke. Yeah, but okay. Yeah, we're good. It's working. So let's now go again for our quantum user inside the game. Let's add a. I think this is a. Oh, this is the ASM dev. So I'll create a new folder here for. So let me create a new folder for components and data. I'll call it QTN. So let's see if this works. Because then I saw that I can use quantum QTN file. I'll call this thing inputs. We'll create separate files. So this inputs quantum QTN asset. Okay, so it even finds. So can I open this guy? Yes, great. So input. Let's see if this is working again. Let me double check here now. Hello? Oh, yeah, it should be working again. So I connected here. It should be charging as well. So sorry about that. I don't know how much you guys missed, but we have our system running. Yeah, the battery on the headset, I hadn't charged it in a long time. So sorry about that. It is working. So we have the system running and I'm starting to do the input. I was explaining that I could overly optimize this and already do bytes compressed angles for the direction we're moving towards and so on. But semantically, even if I do that refactor, what we'll set and get will be a vector 2. So I'll just start with this and even also test what the quantum data compression is going to work with. But what I really wanted to start here is that how do you do the actual first-person shooter input types. So what you need is two angles. So you need one angle for yaw, which will be your rotation movement done with the mouse, and you need another angle for pitch, which is going to be how much you're looking up and down. These are going to be clamped, and we could send these as absolute values, or we could send these as delta values. So both options work, but because the trick is not about this, it's about how we present the view to the user. So it is super important that the camera reacts much faster than the quantum simulation. So we're going to leave the movement of the character, use the quantum interpolated last two ticks thing because it's super smooth with the rendering. But the rotation, we're going to ignore the one coming from quantum, and we'll actually snap it exactly to what is the current accumulated local input on the current rendering. So this is a very important thing when building an FPS. And I'll add a couple of buttons here. So I want to have one for jump, and I want to have a button for fire. We'll get to that. So, okay, this should all be auto-compiling and generating everything. So just checking comments, all good. So we have now inputs. We need a new QTN to create a component for linking the player to control this character. So it will be in this case a component. I'll call it player link, and it will be basically entity ref using the C style. Player. Oh no, sorry, not entity ref. A player ref. Player ref. Who's the player controlling this guy? I'm not gonna do a lot besides this for now, but assuming Quantum has generated all the necessary code, it did. So I can then come here on the system, and I have now this new component called public player link. I'll call link, and what I can do here is I can move this with the direction that we are asking it to move with. So filter, oh, sorry. We need to collect the input for that. So var input equals frame.get player input for the player who is controlling this character. So we get the input, and then we have input. It's also a pointer. Direction, we use this direction. This thing is asking a 3D direction, but I want the 2D, so I can just make this go to X and Z, the 2D one. So that's what we need. I'll also, should I move and jump or jump and move? Good question. I think I should jump and move. Filter.cases C dot jump if we have input jump dot was pressed on this frame, then we'll jump. I'll use all the default config. What do I have to pass this parameter here that I forgot? Frame, always frame. Forgot about that, sorry. So that is it. And with this, I just now need to add this component to the prefab, to the character that has it. That is my character. Player link. And I'm not spawning this yet. I'm doing one player only for now. So I'm going to predefine this to be for the first player, saving everything. So I shall have control of this guy. Just movements and the doesn't seem to be working. Why? Oh, because I'm not linking the input. So it's actually being controlled by me, but I need to now check how am I sending input. It's this script called default input. So let's add some inputs here. That's going to be a very important part of what we're going to do here, because that's where we're going to grab the current accumulated inputs and send it to Quantum for consumption on the simulation, but we'll also accumulate at the Unity frame rate with the regular late updates I would probably use here, because we want the rotation of the character, the mouse look, to be ultra snappy. You will use what we have on the predicted frame of the character plus the accumulated that's rendering on it. So that makes the mouse look absolutely snappy. This is basically mandatory for any first-person shooter. It doesn't matter if it's Quantum or Fusion, whatever, you always have to use this technique. But to start here, we just need to grab the two axes. So let's call x equals input. I need the Unity engine input dot get axis horizontal. I'll use the standard input. It doesn't really make a difference for what we're working on here if we use one or the other. So I'll use this, and then my input dot direction equals new fp vector 2 using fp dot from float unsafe x fp dot from float unsafe y. So this is my direction, and my jump will be jump. It's an important trick here. Never use Unity's state machine for input saying get get mouse sorry get button down, because get button down only triggers on one Unity update, and this may not align with the quantum polling input, which is fixed in our own ticks. So you must use the current state of the button, which is always what is it pressed or not? It doesn't matter. Quantum gives you the state machine in the simulation for was pressed and was released, and that's what you use. So I think if I don't have one, I can actually just use the get key, which is easier. So same thing, not get key down, get key up. So key code space. So I'll just use directly space here for testing. So let's see how this plays now. Okay, so Jonas is telling me that I should not use the debug input, but actually create my own scripts. We shall do this because our own input script, because this one is overhauled when you update the library. So we'll do this before we move to the next step, but let's just test it real quick here because it is already done. So let's see if this is, I'll position the camera in a different way as well. Well, I noticed that the jump is not working, so something is off. So what is the mistake I made here? So I'm passing the input, I'm sending with a direction. Jump is also using this current state of the key. So why isn't this working? It's a test here. So this stream is a bit delayed, so I know that the guys are gonna point what my mistake is. Oh, that script is not running. Maybe that's why. Oh, I know why. It's not, the script is right. I forgot to add a player. So I'm running as a spectator here. So Quantum 3 has dynamic player add and remove capabilities. So unless I explicitly tell it to start with a number of players, so I have 0 local players. So I'm starting as a local spectator of a game that's just running alone. So I'll actually add my local player. I don't have any specific player avatar thing. I can use this if I add a system to spawn. We're gonna use this later, but for now we'll just test this. So now that I have one player, my input's being polled. So you see I can actually jump now. Have to press, and I can also move as expected. I'm not normalizing the vector yet, so I shall do that if the diagonals are being used. But yeah, we got it. So let's see what should be next. I think the next stuff would be to attach a camera, but that's so annoying to do that I think I will start with the already with the input stuff. So let me think here. So I'm thinking about sending the yaw and the pitch as the delta, as they accumulated since last time we polled. So first thing we're gonna do is we're gonna copy this whole script and we're gonna create a new one because we need to replace it as Yona suggested. So let me go back to my own code here. So where should I put this? I'll put this one here. No, this is game. Maybe I should. I'll put it here also. All these view scripts. I'll create a new C sharp. I'll call it local input shooter so we know what it is. And I'm gonna replace the whole thing with what we had and call it local input shooter. Any about here? I have warnings coming from other people. Okay, so this one, sorry, this one needs to go in the runtime because that's the Unity runtime. I'm a noob on Quantum 3 view framework and everything. So let's see if this one works fine now. So yeah, then it compiles the callback. So that's runtime. So that means the Unity controller code and so on. So we just have this new input. We can delete the code I added to the other one. So it is the original one more or less. So we can give up on this debug one. We're gonna use our custom one here, and I will start coding on it. So, but now I'm gonna replace it here. So this guy will have this script and not this one. So this shall work just like before. Just confirm. Yes, jumping, all good. Now let's code this right. So what we're gonna do here is we're gonna accumulate from Unity's late updates. We're gonna accumulate the rotation stuff we need, which is essentially so I'll even store this as a float for y'all delta and I'll store a private float pitch delta. I'll use deltas. And what we're gonna do here is we're gonna accumulate from the mouse input into the yaw delta on late updates, and that's what we're gonna actually use to show in the camera. The camera is gonna be the current simulation rotation, the latest one we have in prediction, plus the delta accumulated from the rendering on Unity that may render a few times in between quantum simulation ticks. So what we do here then is that we do yaw delta plus equals Unity engine dot input dot get mouse get is it axis, or I think it's mouse axis, right? So how do we grab the mouse input? We can also get the raw mouse input. Guess this again. Mouse. Okay, let's see. It will have to be on good settings because I'm using this. Oh yeah, mouse X, of course. It's mouse X and mouse Y. I could get the axis raw in this case. Get axis. I'll just use the regular one in this case. So mouse X. That's y'all. Yeah, that's y'all. It's mouse X. And then pitch delta will be mouse Y. We might need to invert. We'll try later. But this is the pitch delta. Pitch delta. So we'll update this with the rendering. And when polling the input, what we have to do is we have to send the current deltas we have and then reset the deltas, because then we accumulate over multiple Unity renderings into this delta. We get all the accumulated, send as the regular input. This is going to be incorporated into the main rotation of the character and pitch of the character, and then we don't need to have this anymore. We reset it and let it accumulate again. So that's essentially the framework here. So the yaw we send is essentially FP from Photon safe from the yaw delta we have, and then we send input dot pitch as FP dot from Photon safe our pitch delta. So that's what we send as input, and now we reset yaw delta equals 0 again, pitch delta equals 0f again. Okay. Yes. I'll not do any pitch yet. I will start with just the yaw, maybe even for the whole demo, because then we don't waste a lot of time doing a too complicated setup. So what I'm gonna do is I'm gonna attach a camera, make it follow this guy, and put some visuals so we know where the guy is facing. And what we're gonna do is we're gonna run the simulation very, very, very slowly, and we'll try accumulating and without accumulating the pitch, and we'll see the difference. But this is all correct already for yaw and pitch. So what we need to do then is we need to make sure that the rotation of the character, we also need to make sure that the direction is now proportional to the rotation. So okay, but we'll do that afterwards. So first we need to compute the rotation here. So we need a new component for that. So I'll just use the same stuff here. Component. Let's call shooter shooter rotation, because it's the person who's a shooter rotation, or maybe we call character rotation. Character rotation in aiming. So we need an FP yaw and an FP pitch to accumulate what the deltas we send, and this is going to be the main rotation of the character. So that also means that, let's see if that has been generated. Not yet. Done now. So now we can add this guy also to our filter. Like character rotation as well, and it means we can have filter dot character rotation dot eol. Oops. Oh, I made a mistake on the name. Eol. It will fix itself. Eol equals input. Oh, not equals, plus we accumulate. This is a delta, so input dot eol. We just keep accumulating this. We'll also rotate the character itself. So let this whole thing compile because I made a mistake on the naming. It's fixed. We should also rotate the actual character by doing filter dot transform rotation equals FB quaternion dot not identity dot from Euler. So it's rotation in degrees, x axis and z and y axis. Okay. We shall. I'm thinking here. So this is in angles. Should I do yaw and yaw and pitch? Yaw and pitch. That's in angle in degrees. So I'll keep it as it is. So we will just use 0, FP 0 to be absolutely correct. Then this is gonna be the accumulated yaw, and this will be 0. So this is our rotation. And then the movement has to be the converted direction, which is we're going to use this rotation and apply to this direction, because if it is forward, yeah, if it is forward, we need to rotate with that. So that's because then we can strafe. So direction equals character rotation. So if you guys don't know, rotating something with a quaternion, you just multiply the quaternion by the direction, and then you have the rotated direction. So this is rotating with the yaw. So forward is where the character is facing now, and backwards and sideways is strafing. So that's all we need, I think. Let's just add some cues to the character, like glasses and something, so we see it actually rotating. Yeah, let's see this guy from closer. Where is the z-axis here? So let's add a little cube that will be on x, on y is gonna be 0.25, 2, z is also be 0.2, 5. Then we'll put this thing kind of like here. Let's make it slightly smaller here as well, 0.8. And we don't need collider to these guys. We need a nicer material. It's default material, so let me put it here. So for now, this material. I'll just create something black, and then I make this little guy black. Glasses. Yeah, so now we can see the character. We are already sending y'all. So it should already rotate the character. Let's make this camera slightly nicer to see, even though we're not yet attaching the camera to the character itself. But let's make this thing have it's actually 15 degrees or maybe 30 degrees. Let's see. Yes, it should make this. I need another material for. Can I have let's call this guy black. Let's call this guy floor. Do I have a tilting? Do I have a tilting texture I can use here? Coming with Unity. So all buttons. Yeah, checker gray. It's the game. So add this to the scene. So tiling 1616, 32. And that's enough. So you can see it better. So let's see how it looks now. Yeah, I need to add that component to the character. Forgot that. So we have the character rotation. So the what happened was the character was not even moving anymore because it did not match the filter, because the filter is expecting to have this component and I forgot to add it. So now that I add the expected component, save everything, it should again go down to the floor because it matches the component, and it is rotating. Yay, yay. So rotating the mouse, the guy actually rotates, and moving should be, yes, perfect. So strafing backwards, and I can rotate here. It is a bit, it's not sensitive enough, so um, let's add a multiplier that lets you control how fast you want the mouse to be. So public float mouse speed or sensitivity equals sensitivity. I'll go multiplier. Let's not try to do something super accurate, just letting us capable of controlling this a bit more. So use the sensitivity multiplier. I'm starting with 2x, so this should already be easier to control. Sorry. So we have the accumulated rotation, but we're still, yeah, so 2, perhaps we should make it even a bit more pronounced. So that's on the local input. Sensitivity, let's make something like 5. It is not best for playing with shooters. With shooters, it's better to be not, it's better to be like it is, but I want to show something here. So one interesting thing is that for who's watching or whoever watches this video later, is that you can see my mouse moving here because I still have the cursor, and you see how fast the character rotation reacts to it. So it looks like it's instant, right? But it is not, because what we're doing here is we're moving the mouse very fast and accumulating on the deltas, but the rotation of this character here is being controlled by the quantum entity view, which is interpolated. So I'll show something interesting here. I'll change the update rate of quantum to be, oh, that's an interesting point. No, yeah, no, it will still move with the same speed, but we will have a bit more latency if we run quantum at a slower frame rate. So I'm going to run quantum simulation. I'm going to exaggerate a lot. So I'm going to run, first I'll run at 30 because it will not be super easy and it shall be a good uh, update FPS for a mobile or maybe WebGL game, but it's still not easy to see in this case because it is fast enough. So what I will do now is I'm going to run this at 10 or maybe even 5. The speed will still be the same, but we shall notice a delay in between when I move the mouse and when you see the rotation. Can you guys see that I move and then it takes a while to start moving? There is a delay. So this is an absolutely no-no. You should never have this no matter what is the simulation rate you are running. So we'll still, in the end, we're going to use 60 or 30, which is nice. You might not notice, but especially when you have a first person perspective, this is very, very noticeable. It feels really bad if the rotation looks like this. So I'll show how we fix this. Yeah, that's correct, Yahya. Both, so Quantum 3 is a Unity package now, so it's all part of a Unity project. It's still well separated into assembly definitions. You should still do your quantum parts of the code independent of Unity, especially if you plan to have simulation running on a plugin or something like that, like a server plugin. But yeah, it is much more convenient. You do everything from inside Unity. Also, data-driven system setup like you saw. That's all correct. This is all on the docs already. Everybody who has Circle so this is being was shared only on Circle, so you shall have access to all this already. Um, so okay, so let's fix this because the simulation is doing everything correctly and the speed is actually correct. But what is not working here is that we're not exposing this to snap the character, the local character, to overhaul the rotation that comes from quantum and actually snap it to the one that you get from from the accumulated pitch and yaw here. So what we'll do here is we're gonna create a new script. Yeah, actually, I want to get my character. So we have this entity view script here. I want to create a custom entity view. So we shall be able to add here a new C# script that I'll call shooter entity view. And I think the quantum default entity view is a regular, it's not AI, it's using quantum, it's not on any, oh yeah, it's on the quantum namespace. So I'm gonna close this because we're gonna extend this guy with our new one. So we don't need to look a lot. It has a nice way to extend it. So shooter entity view. Let's make this thing be part of namespace quantum to match. So we don't have to do a lot different. Maybe we don't need it to be on quantum namespace, but we can do that, I guess. So this will extend entity view. And there are a couple of overrides we can do. The one I'm interested in is, it's not an override. How is it the apply? How can I extend the apply transform with the new one? So let me take a look at the methods here. So, oh, I made a mistake. So it is called something else. I made a mistake. So I know the fix is gonna come from the other guys, but quantum entity view, that's the name of the class. So it's new name. So quantum entity view, that is the one. So that one I have override. Apply transform. I knew this. Yes. So what we're gonna do here is, so let me check what the base apply transform does. So we're gonna use the position of the base, but rotation we're gonna overhaul completely. So we're gonna let the rotation apply the one with error correction and everything, and the interpolated one, but I'm sorry, the position, but the rotation we're gonna do differently. So we will cache here. I'll, I'll not bother much with the Unity specific thing. So I'm just gonna drag here the sibling quantum. Oh, sorry. This is the entity view, so I do have. Sorry. So I don't get the game as a parameter, so I might need. Do I still? Yeah, I still have all the original stuff. So I have the default game dot frames dot predicted because I want to get the very latest version of my character rotation from the predicted frame. That's the rotation I'm going to apply together with the added to the local accumulated yaw. So for the local character, for a remote character, I'll just use base. So I'll just use the original apply transform. So we'll have to match for that. Um, so couple things we'll need here. So thinking, what is the best way to handle this? So who's mentioning something to me? Yeah, Jonas corrected me. Thank you, Jonas. I realized it already. Uh, so let's just double check. Okay, no new comments. Cool. So I need to grab a couple of components here. So I need to get the player link, and that would be. So first, let's get the frame. Our frame equals the predicted frame. I'm interested on the latest data we can have, always. So what we'll do is player link is going to be frame dot try get. It's such a small one that it should work. So we have the entity ref. Is the entity ref? Yeah, entity ref. Try get player link from our yeah, of course. Oh yeah, it's because it's a try get. I'm not doing get. So if frame try get, I've been spending too much time with Quantum Unreal that I forgot a lot of the little patterns of Quantum. So if I have the player link, I check if this guy is a local guy. So session quantum runner dot default dot session. So if we are also a local player, and session dot is local, this would be link dot player. It's not is local. This is the is local session. Is local player. So this is the player for the player ref is local player. So if this guy is a local player, then I'm gonna do this, because if it's not, I'm gonna use base. I'll use the I'll use the original code. If it's a local player, I'm gonna do the trick, which is I do this, then I also grab the rotation. So I would use the same pattern of frame try get, but it will not be a player link this time. It will be the character rotation, C rotation. I don't need the if here. So there's an extra. So if I get the character rotation, okay, now what I do is I do transform dot rotation equals quaternion. Now a unity one dot Euler. And then what we do is we grab 0f. Then this is the interesting part. So what we need to do here is we're going to do the latest predictant data that comes from, from the character rotation dot y'all as float 0f. We have to accumulate here the one from the local input. So I have to have a reference to the local input, um, which I can do when I first do this guy. I can grab the reference of that component is one thing we could do. I'll just do that, which is shooter local input shooter. I'll call this input. It doesn't have it can be private. Call it input. Can I call it input? Yes. Then I can do void start. This is safe for this particular case. I can do a very bad pattern here, but it is as I said, I'm not doing the best Unity. What if this is fine here? I know, this is horrible, but that's what I'm gonna do. Dot get component for our local input shooter. This will store here. So now we have a reference for the accumulated inputs, and what we can do is during our apply transform. I noticed one thing though. Our apply transform, then I can add here plus input dot. Oh, yeah, it's not public, so we need to make this to public. Or we create a getter, we create a better pattern for that. So we have the yaw delta. So this is already a float. So basically get the latest predicted plus the one that we have accumulated. I noticed one thing because apply transform does not run on late updates. So perhaps I should actually ignore this part, should let it do as it does, and I should maybe add a separate script and just do it from the late update instead. That would also work. It would be a bit simpler. Or I can just do it from here. It doesn't make much of a difference, right? So, but it is better to do it like that. So let's do it like this. So, because then we can organize the script order to make sure this guy runs after the input. So we absolutely grab the latest mouse input. So what I can do is I can do all this. And then I can let this guy work normally from when he runs. And I'll just overhaul the rotation from late updates. And that shall be enough because it will only run for a person who is a local character. If it's not a local character, it doesn't matter. this should already work, although it is not exactly. So I have a lot of. Yeah, get components should work. Just checking if there are messages. Nothing important, so we're good. Okay, let's test this. This should already fix the thing. Although to be perfect, we need to make sure that this delete update on this special entity. Oh, we have to replace this guy by the new one then. Can't add script. Why? Doesn't say why. No errors. Okay. I remove the entity view and then I add. Yeah, because it was the same type. So you have the shooter entity view. See if this is all working. Yeah. And of course, I'm running at a high update rate, so it is okay. Let's test now by running on a lower. Oh no! See, it was super fast, super snappy, but it's actually running at 5. So if I didn't have that code, it would look super slow. But because I have that code overhauling the rotation, it's actually super snappy. So you see that immediately I move the mouse and the thing immediately moves. That's what we wanted to see. Great. We can go back now to use a reasonable update rate for the game itself. But even if we put this in first person perspective, it would be absolutely snappy. So that's a pattern that you have to always use. You accumulate locally. So you accumulate locally the delta input from Unity's rendering rate. And then what you send as input, being it Fusion, being it Quantum, what you send as input is the accumulated stuff you have, and then you reset the accumulated. But because you're going to have renderings in between different simulation ticks, you keep accumulating. And you have to make sure that your view scripts, maybe the positioning is still being interpolated, but it's mandatory that the rotation to be ultra snappy to the mouse input you're doing. Otherwise, it feels really, really, really laggy. So this is what we're going to do here. And yeah, so that finishes part 1 of what we wanted to do. Let me check what I... Let me see here on my list. So we finished actually. So we have a list of things I want to do. So I'll just add them as a comment somewhere. So it can be something. Why? So let me just add some stuff here. So this is the list of things I'll be doing. So we're done with this pretty much. So I'll leave snapshot interpolation for last. We have the option to do one of these two now. Either predict the local character only or do lag compensated raycasts. I think I'm going to start with the complicated one, which is lag compensated raycasts. So let's go back a bit here. So what happens here is that when you have an online game, there is latency. We always try to hide latency. So Quantum predicts input of everybody, and that works for a lot of interesting game genres, that it predicts the input really well, and And you can extrapolate the movement of the characters by extrapolating the whole simulation, especially for stuff you see. That's the whole principle of how quantum works. But on a shooter, you don't want that. I already explained why at the beginning, that you want to see things accurately as they happen with a bit of latency, because you don't want mispredictions at all from the other players. And that means that you're going to be seeing stuff in the past, and when you shoot, you're shooting not at the position of where the simulation will be when the tick you shoot at is finally simulated on verified frames, or finally simulated on a server in case of fusion. So what you want to do is you want to make sure that the server, or in case of quantum, the verified frame simulation, has the right data to compute the shots you do at the timing as you see them. So that's a bit tricky. So you need all these things together for this to work. So you need a smooth snapshot interpolation where you see remote players without prediction, but not seeing the jittery verified frame or snapshot from the server. You see a slightly behind interpolation of these. Then you need to somehow inform the simulation in case of quantum, or the server in case of fusion. Fusion has this by design, how far you have your prediction compared to what you see of the other players with the snapshot interpolation. Then we need a data structure to be able to compute the raycasts you do for shooting against moving stuff, to do it with the data as you see. And here's the trick we're going to do. So whoever is watching, there's a bunch of people watching, so please pay attention, because this is the super clever trick to do this in quantum. Yeah, it is really this. It's super clever. So what we're going to do is we're going to store a small ring buffer of previous character positions on a component on the character itself. In a component. Why is it complaining of the component? Component. We'll store a small ring buffer, and we'll basically keep adding to these positions as we simulate the movement of the character. And what we do then is we will inject capsule colliders into the physics engine for each of these positions. We'll use a sequence of layer numbers to mark the corresponding collider time. So let's say if I store 8 positions of my character, and I'm running at 33 hertz. Essentially, I have the current position, I have the position current time minus 33 milliseconds, the one minus 66 milliseconds, the one minus 99 milliseconds, and so on and so forth. And what we'll do is we'll add them to different layers. So the current time is going to be, let's say, layer 0. We'll just keep the default stuff. Then time minus 1 tick would be on layer 1, and so on and so forth, all the way to minus 8, for example, because then we can have up to 266 milliseconds of 30 hertz game of lag compensation. So we'll add them with these different layers. And the reason to use the different layers is that because when we're going to be raycasting, we're going to raycast against a specific layer. We'll be able to use other layers for other things. So we have 32 layers. We're going to just reserve 8 layers for the lag compensation. You can do this without the layers, but it becomes less performant. The trick of using layers is a nice way to have super nice performance on this system. So we're going to inject all of these past colliders on specific layers matching previous timing. And then we will when we shoot, we raycast against a specific timing. And what is the timing that we raycast against? That's gonna be based on how we see. So we're actually gonna embed that into the input. So the input is gonna involve the client informing how far is his prediction compared to the snapshot interpolation he sees. We're gonna use a byte for that, just in the offset. And that's what we're going to use here to compute which layer to raycast against. If 0, the local one, if we're not too far behind, or if we're going to be shooting with a much further back raycast. Then the interesting thing is that before you guys ask, isn't this like unsafe because the client is sending kind of like how far he is looking into the past? Well, that's exactly how shooters work. Even server-authoritative fusion or any AAA netcode you see, the clients can fake ping. They can pretend that they were on a higher ping by tampering with network or whatever and informing a different ping. So it is part of the input feedback loop. And the point is that the lag compensation system only allows you to go so far. We have a clamp of how far behind you can pretend you're shooting at. So we're limiting here, let's say, to defined 8 ticks. But you can configure this to use a tighter one. So essentially, it's not really a big deal. It is the clients inform the difference they are looking at. So and if you inform it too far in the past, you kind of like also allow you to be shot before the other guy. So you can compensate with that kind of. So if you have person on a super high ping, as reported by the input, you can, for example, put them last in the shooting list for each tick, so you kind of give a priority for people on high ping. So, but that becomes very specific, right? So I'm not going to dive into that. The point is that it's not a big problem to send that as part of the input. So we're going to use a sequence of layer numbers on this ring buffer, and that's what we're going to use. And so we'll need here to have a special byte for the I'll just call it time offset or tick offset. It is for the lag compensation system. So I'll comment it here for lag comp. So we're gonna add this to input, and that is gonna allow us to choose which layer to shoot against. Then there is even an extra optimization we can do, which is just an optimization. So this is already an optimization, but we'll do it from the beginning. Check every tick, check, create a mask with the offsets, the tick offsets, where at least one player is shooting at. Because then only inject colliders corresponding to the necessary times. So this is the interesting part. So we can add this extra optimization, which is most of the time nobody's shooting, so we don't inject any lag compensation collider on those ticks. What we'll do is we're going to inject the lag compensated colliders on the ticks that there is at least one player shooting, and we only inject the colliders at the layers corresponding to the specific time at which these players are shooting on that tick. So that's great. I mean, we're going to occasionally be injecting the colliders, not all the time. And it's kind of like just some clever tricks, but we'll do it like this because it doesn't hurt much. The most complicated part is going to be the base stuff anyway. So let's create here the component for lag compensation. It will have a buffer of a certain struct. So let's start defining this struct first. So struct for lag compensation I'll call it hit box or hit. How do I call it? It's normally you call it hit box or hit capsule or hit. I'll call it hit box transform. I could use a full transform, but that's just a full quaternion. We don't need all that. We just need the FP vector 3 position. That one we need full. And we just need the. We don't need any yaw. We only need the position actually in this case because it will be just the same capsule collider for the character. We're not doing animation. Funny enough, Quantum can do very, very accurate light compensation if you use the Quantum custom animator and you bake in the animation position curves, but that is not normally possible in a shooter because you need blending. It's a bit more complicated. So most of the time you are just interested to validating if the shot is really at the body or at the head, and then you let the clients accept the exact. Oh yeah, this splatter is gonna be this or that. But basically you want to know at which part it is. So I only need the position here for this. So I will still keep the hitbox transform as a struct because we may want to add a couple of more things to it. So we might want to have the layer timing added to it, although we do not need because that would be done at the collider, so it's a bit redundant. But maybe it is because I can do this with a list or with an array. I'm gonna do with an array. So okay. So we'll just use an array of the hitbox transform type of size 8, and we'll call it buffer or hitbox transforms or transforms. Transforms. Oh yeah, of course I need something else. I need to have a reference. Yeah, I need to have an entity ref because we need to create entities with a collider for each one of these that we're going to be injecting, and this entity is going to point back to the main entity. So when you shoot at, you can know what is the actual character, who's the actual character. So we need the entity ref of the hitbox of the uh, collider entity, and we'll need another component for, I'll call it hitbox entity actually. Hitbox entity, because this will point back to the main entity. So we need to know who is the hitbox entity we're going to be updating to this. We don't actually need the layer to be here, but because this is going to be computed every time, I will keep it here just for the sake of readability. But we'll replace this every time we do it. So this points to this, and we'll have to spawn these things. So another thing we'll need is we'll need to know what is the entity prefab we're gonna spawn per character based on this. But we'll do. Sorry, I have something calling here that I need to stop. Just give me a second. I think it stopped, so it's okay. I'll just do a quick scan here if we have any other questions. So nothing. Good. So back. Okay, so where do I start? I need a new system for this, so I think we should start by creating the new system already, and then we start coding the cool stuff. We can also add a few. So let's call this lag. So we'll need a few systems. So lag compensation system. The lag compensation system is the one that injects the entities at the beginning, that injects the colliders at the beginning, that positions the colliders of the slave entities. I'll use it also the to spawn the colliders for each for the spawn is the separate entities for each character that's actually when the regular character is spawned. So I'll use this system for that. So the lag compensation system. Um, so let's put this guy on namespace quantum. This will be, you know what is cool? So this thing, we won't need to have a super complicated system for it, so a filter for it. So it will be a much simpler filter. We only need the transform, and we need to filter the entities that have. We need transform 3D, so unsafe. We don't need character rotation. We don't need player link. We don't need character controller. We only need the transform and the lag compensation component. So we only need this guy to organize this whole system. Um, so this guy is going to be a system main thread filter with its own filter. So we need to then create the update method. I like to move this guy up. Okay, so now we're gonna update each one of the the things. But first, I'd like to spawn these guys. I'd like to spawn the other entities that we'll need for each one of these characters, so we can go updating each one of their collider and transform. So to do that, I'm gonna use an iSignal on components added for the lag compensation component. So whenever I add a character or something that has lag compensation that can be shot at with lag compensation, I'm going to spawn the necessary entities and add the necessary components to it. So what we're going to do is we have the entity, we have the component, that's all we need. So we'll do the following. So for 0 I equals component transforms dot length. So we'll spawn a new entity. So we have a new entity. We're gonna add a transform, a capsule collider. I should create a I should have I should have an asset ref for this. Oh yeah, different lag compensated things can point to different entity refs, entity prototypes, because they may need different sized colliders. Yes, that's going to be important. So what we would do then is I need to have here an asset ref for entity prototype. I think I can do it this way now. Hitbox prototype. So this will be your hitbox prototype. Let me make sure this is gonna compile. This shall compile. So let's make sure all code generated stuff is done. Uh, so this guy has the asset ref already, so we shall be able to create it with a component dot prototype. So convenient. So we create with the right prototype. So we're going to create a prototype that has only, it doesn't need a view, although we can add a view to watch how things are, but I don't plan to. Um, we may. Or maybe we just create, no, it's better to create some debug drawings, so I'll not do that. So, um, da -da -da. So we created this guy. So I'll create this guy disabled by default, because then we're gonna enable or not based on the update here, based on the amount of positions we have stored here. So I need to have a couple more things here besides the transforms. I need to have an int32 or a byte for added. How many I already added? It starts with 0 because I'm just gonna go through the added. And I need to have also a byte for the cursor because this is gonna be a ring buffer. So we'll go around this guy. So we always inject into the custom cursor position and we cycle through this. So you will always have the latest position at the last one. Okay. So code generate again. Light composition system. So what we do here is we need to go through. So this guy has to go before the physics engine. So I'm thinking here. There is a system that must inject the lag compensation hitboxes into the physics engine. This one must run before the physics engine. There needs to be another one running with the movement to get the new movement and inject. I'm gonna reuse the movement. No, I should not use the movement. I should use a special one for that because I may have stuff that's not moved as a character controller. So I'll use a separate system for that. But let's start with this one that injects. So this one is gonna inject it would just inject into the physics engine using the timings and the queries that exist. So, and we'll add the optimizations later. So this is creating the, we're creating the entity refs, but what we have to do then is, so we have so we need to do, sorry, I forgot this. So we need to add the references here. So hitbox, so the transforms. So each of these transforms I dot hitbox entity equals E. So I keep a reference to this E. And I need to do one more thing, which is if frame dot save dot try get pointer to the component called, so we have this component called hitbox entity pointing back to the main entity. So this is going to be important for when doing the lag compensation. So if this guy has this, which we will have, out var hitbox entity, then I do hitbox entity dot main entity equals entity, which is the guy who has the lag compensation component. So we need to have this double reference here. So this part is finished. I don't need to inject the layers yet. This is going to be injected from the movement system that performs the one that runs together with the movement system that does the update with in sequence. This one here must run before the physics engine. So this one here we'll inject the entities if they are to be injected. So, but the optimization or about if they are to be injected or not, I'm going to do later. So what we have to do here is for, so we need to have the count. So let me just do, so var count equals filter dot leg comp dot added. It does not matter where the cursor is because we always start from the 0, 1, and we'll have the layer timing injected there from the system that the other system that's going to do that. So we don't care. We'll just inject the ones we need. And later we will not we will disable their colliders if they are not needed based on the inputs mask that I talked about before. But what we'll first do here is we'll just go through these, the ones we need to. Var smaller than count. So what we'll do is, so we have the data in the leg comp, and we have the entity. So we need to change just the transform. We don't need to touch the collider, or maybe we need to do the collider as well. So if f dot unsafe dot try get pointer for, we need the transform 3D. So let's get some variables here. It is so filter dot leg comp transforms I dot, so we have the position, we have the layer, and we have the hitbox entity. So I'm more interested in this. So hit entity. So we need to get the transform of this guy out var t hit entity. And we also need equals here. So we also need the collider. Oh, I think we will need to know the specific collider type in this case. Because I want to disable the collider, I don't think I can grab the collider no matter what it is. I should be able to do this with a different pattern, checking what type of collider I have, but this is not the type. What is the name of the type? Oh, this is the damn Unity engine one. Oh, I said I am rusty. Quantum has a physics collider 3D, and the capsule is the damn shape. I'm already afraid of the guys correcting me in a few minutes here. So just waiting for that. So okay, let's move on. So I have the collider and I have the transform. So what I need to do now is transfer the data from the leg comp. So I need to make the transform position. I'm gonna do to each one of them for now. Oh, there's something interesting here. I'll talk about it later. So I'll put the position to be equals filter dot leg comp dot transforms I. dot position. I think I should have a copy of this guy here. So hit box data equals to verbose here. So I know it's not the op, it's better. So we get this here. Then we're just reading, we're not changing the data, so we can just have this copy here. So transform is going to be the hitbox data position, then the collider layer will be the hitbox data dot layer. And so here's the thing, I think I should not have this count here. I should actually do it with the full length of this guy. And what I do is if the I is smaller than the amount we have added, I'll call this added. We enable the collider, and we don't enable the collider for the ones that we have not added yet. It's essentially this is a true. So collider dot enabled equals added. This. For now. Later, we're also going to check the input mask and so on. So, but for now, this is okay. So let me see. So this should inject. So let's think here how this, we can test this very quickly. So this will spawn 8 copies of a specific entity prototype we define. And this will, if I add these positions, it will place all these copies into the positions I keep doing there. It will do this over time. Okay, so we need to have a, before we test, we need to have this second system. So I'm gonna create a second system here that will be a bit similar. So this is the lag compensation injection system. So this injects the collider, and I'm gonna have another one. I'll call this one injection system. And I'll call the other one lag compensation update system, because this one will update, will write into the lag compensation component. So what this will do is I will just add to the component at the cursor position. So we'll have, oh, I don't need the onAdded on this one. So I don't need to have the interface. This one is just to update. So I'm gonna actually change the added, so I don't need this. So I'll go through, no, I don't go through every transform. What I do is I need my own transform and my lag compensation. I'm just gonna add my current position to it. So what I would do here is, if I am simulating this thing, I have to make sure that I don't do this for non-predicted entities, but we'll talk about that later. So this one must run for every one of them. This one must not. Yeah, that's interesting, but I'll talk about that later. So here what I do is I do filter dot lag compensation transforms, then I get the cursor position, so current cursor position, so filter dot lag comp cursor, var cursor equals this plus plus. Then I'll update on this one, and it's already updated. I have to make sure the cursor goes around the length, but I'll do this. Let me do that already. So this guy percent equals filter dot leg comp dot transforms dot length. So it never goes. Huh? Cannot convert step inside. Okay, it's because it's just an int. Can size is small enough. I can do it. Then the current cursor transform dot position will be my current position. Then, oh, now the interesting part. What should be the layer here? Do I know the layer? No, the layer is... Oh yeah, I have to update the layers on every one of the others. I have to start with this cursor and update all the layers to be backwards. I have to go backwards and update all the layers to be... Yeah, I have to do that. So this one will have the layer 1. So this must have dot layer equals 1 because it's not my current. Oh, it is my current position, but I'm updating this. Oh, this can run after the movement because it only matters to do it for the next frame. That's good. Because then my current position will be 1 and I have to update all the positions for the next frame, all the layers on the next frame to be plus plus. Yes. So I can start with 0 actually, and it will update all of them to be plus 1. Yeah, that is also better. So yeah, then I just need to do dot layer plus plus. I don't know if you guys understood this, but when I add a new one, I position it at the cursor position and I make it 0. And then I update all of them by 1, meaning that this one is going to be 1 on the next tick, and the one that was previously 1 is going to be offset 2, the other one is going to be offset 3, and so on and so forth. So every one that I update keeps, as time passes, as every tick passes, it will have a new, it would be considered older as we do it. So I have to mark something. So this one here should not run on prediction. Because this should we should just use, and this one should run on prediction. This must run on prediction. So we inject also the remote players in. So we will not simulate the movement of the other players, but we will have them in the physics engine and the lag compensated version of them as well. So that's an interesting aspect that we have to keep in mind. So this one, not. So this one I can actually, if I'll do that later. So let's first make sure this is correct. So I think this is going to be updating all the time with the positions. And yeah, let's go to Unity and create the whole thing. It should be possible to test already. We'll create a transparent guy for this. It's good because we need to get a few I'll create a few prototypes here. So my character will be a prototype. I also want to duplicate this guy, but I'm gonna do one that will have the capsule. It does not need a shooter view. I can use the regular quantum entity view, the regular one. I can have, it will have a collider. It will be the same capsule type, but I do not need a character controller. I do not need a player link. I do not need a character rotation. What this guy will have is, you will have, it will be the hitbox entity kind of thing that will be spawned. So this, I'll call it leg comp hitbox entity. And I'll create a prefab for it here. And a new original prefab, not prefab variant. I don't need this guy to exist here. And my character, I can now add the leg compensation component to it that will have all the past transforms. Nothing is predefined, but I need a reference to the leg compensation entity to spawn. Here it is. 0 added, 0 on the cursor. That should be it. I now need to add the two systems. So I need to have the injection system running before physics. So let's go back to the it's easy. We get here and we get the sample system config. Okay, so I can replace the culling 2D or the physics system 2D because we're not using that. I can replace this one by the one that we need to run the injection system because this has to run before the physics engine. So I'll run the injection system here. And I need one to run after the movement. So I'll make it 9 systems and I'll have my 9.1, my 8.1 be the update system. I think this is already gonna work, but let's change a bit this. I have glasses on this thing. I don't need the. Well, I'll keep the glasses, but I want them to be. I want a different material. So we have some materials here. So let's create a new one. I'll call it hitbox. Just create a transparent, slightly green thing. Something like this should be fine. Let's have an idea here. So make this one be that. I'll let the glasses be as they are. Oh, I have to apply this to the prefab. I can delete it here because now my character is gonna spawn this. So when I press play, I should have the 8 copies spawned. Wow, already worked. So no errors. Let's take a look at the state inspector. Oh, yeah, actually we can see here all the entities that we have, which are the ones with the as the hitbox entities, but we could also take a look at the state inspector for that. But what I'm gonna do is I'm moving, and you see that they are here. I could actually also include the rotation, but I'm not including the rotation. So this is essentially 8. Yeah, I should remove that glass for the lag compensated one, because we're not bothering you with rotation at the moment. You could add the rotation as well to that, and then consider that as part of how you shot it in front or in the back, but normally that's not really very important. So I'll not do that. I'll just remove the glasses in this case. We don't need it. Why you cannot restructure it? Sorry. Maybe I can edit in place. Let's just play again one more time. Okay, so one thing I'm interested in is taking a look at how the layers thing is looking like. So let's take a look at the state inspector. Because state inspector opened on the wrong place, so let me open it here. Let's take a look at how so we see here the main entity, which is a character, has all the components we have added to it, and this is the one that has these are the entities that are being updated to be the hitboxes, so they have the transform. But I'm not interested in them in particular. I'm interested in looking at how the layers, we could look at them as well, but I'm interested in seeing the layers here. So you see that the layers are changing because I'm adding to the different cursors. So as I move, the cursor is being, the layers are give the different offset. So let's now do the final thing. So the last thing here is that we have to send the input now. So that's already cool. So going back to what we said that we would do. Oh, here, yeah. So we're already injecting a capsule collider engine for each one of the positions. So we have the ring buffer of previous characters' positions. That can actually be done not only for characters, we can do for any moving thing. We already inject a collider. It doesn't have to be a capsule. It can be the collider that matches the shape of whatever that is. It's flexible as that. So inject a collider. Specific, so each lag compensated body can have a entity can have a different entity for its lag compensation hitboxes. We are already using the sequence of layer numbers to match the time offset. That's all done. So done. We're not gonna do this. We're not gonna do this last optimization yet because for that we need the whole input thing. So yeah, I forgot to say then process raycasts only against the mask that corresponds to the desired time tick offset. And this comes with input. So what we need to do now is we need to compute what is the input offset we are seeing currently. And that is kind of easy. So we go to the, it's actually this script here. So when we're polling input 4, I think the callback tells us what is the frame number, which is the tick number. So I'll add a section for this here. So lag comp offset. So we have var current tick. So this is the tick we're polling input from. It comes from the polling method. And we're going to inject into the input the difference between this one and what we'll be seeing in the past. Because I don't have yet the snapshot interpolation system, I'm going to do this on the next one. We'll start just by computing the difference between this one that we're polling input for and what is the verified frame we can see. I mean, the jittery verified frame we have. So what I would do here then is I'll have I'll call it interpolation tick. it will be for now. So we're not querying the whole quantum. I think we have callback dot. Do we have the game? Yeah, we have the quantum game here. Great. Because then we can have frame dot verified dot number. So this, we already have an offset when we are playing this online, and we'll log and see what we'll be sending as this, because this is going to make our shooting be different. And we're just going to make some moving objects soon, and we can test this with this character as we have it right now. So then we have the offset. So what we do then is input dot tick offset equals current tick number that we're polling input for minus the interpolation tick we're seeing. That currently is just the verified frame, but later will be actually a frame a little bit behind the verified one, because we're going to be interpolating slightly behind that. So a lot of wind here today. But this should already show an offset once we run this online, so we might be able to test it pretty quickly. So I think we can also see that as part of the globals, because we have the inputs. Yes, we'll have tick offset here, so we'll be able to see that. So it shall be 0 or 1 here. Yeah, it's basically 1 on a local simulation. We're just simulating the next tick, and the verified one is the previous because it hasn't been simulated yet. So that's expected. But let's try to run this online and see how this gets proportional to ping. I think I can just save the scene, go to the menu, scene, press play. I already have my, I think I have the default game scene, so that shall work. Do I need to add player? I think I already add a player if I do that. So oh, I got an issue on the connection. So what was the error? Huh. I'll confirm that I have the right app ID here. I might need to ping Jonas here because this is not related to what we're doing. So um, so let's see. Uh, I can try another app ID, but this should be working. So I'm pasting this to. Okay, what I maybe I have a mistake. Plugin manager suggestion failed. Yeah, okay. Suggesting me to check the app ID. I'm gonna do that now. So this should be a Quantum 3 app ID. That's how I created it, but I'm gonna confirm it is the case. Plugins Quantum 3. It is a Quantum 3 app ID. I'm gonna use another one just in case, so I'm gonna do this off screen just so I don't share, just to make sure I use one that I know works. So this is not related to the what we're trying, so I'm not gonna bother to waste time with this, sorry. Replacing it with the suggested one. Okay, thanks Jonas. Saving all. Shall let's see if this works now. Let's see the state inspector, so we'll be able to see the input. Let's see if quick play works. Okay, I think it's working now. Yeah, but somehow something is off. Pause. Oh. Oh, yeah, yeah. I did not add a local player, so I thought it would be automatic in this case, yeah. Do I have to do anything on the default menu to have a local player added? Yeah, I know I don't have a camera. This is annoying. We should have fixed this already. How can I disable this? So Photon Max players 6 vsync frame rate. Oh, this is just my nickname. So is there a way? Oh, okay. Got it. Thanks, Jonas, again. So party menu. So I can add here which game object. So runtime players 1. So this is going to be adding one local player. Sorry about that. So as again, same as local, Quantum always starts as a spectator in 3. But if we add a local player, then you get assigned a player index, and it still did not work. Maybe I forgot to save. Because I don't have input coming, that means I don't have a local player. What did I miss? So runtime players 1. Do I have to have a nickname or something? I'm not spawning this. I don't have a system to spawn. Or maybe there is a system to spawn this, but it should already have the pre-built entity. Let me try again. If there was, let's see if there is any error here. No, there's no error. Oh yeah, we have the player added. Why isn't it? Oh, this was the old one, the old game. Yeah, so well, it is sending input actually. Why isn't it? Oh, thanks. So noob error. We don't have we don't have the system config being sent because yeah, that was also from the default. I think Jonas, that should go on the sample. So we should have the sample one also predefined on the menu here because yeah, it creates a bit of confusion. So my systems were not running. One more time, it shall all work now. I think I got it. So I see what you're writing, but I think I got it now. Um, yes, now my systems are all running. I have my input. I can move my character, and this is running online. So I'm running at a nice network ping, but still, looking at the input here, you see that my tick offset now varies. I have some variation, so depending on, I might be a bit far from what I'm seeing or not. So we have some offsets here. So my shots would be soon lag compensated based on that. So we're already sending the information to the simulation. So what we have to do now is the final part, which is when I'm gonna shoot against only the lag compensated layer based on the offset I have. So if I have offset 0 means nothing, I'll shoot at layer 0, which is current. If my offset is 5, I'm going to shoot against offset 5. And that's basically mean that I'm going to be querying that. So I'll do that already, and then let's do one more thing. So how do I'm thinking about adding a moving entity that has the lag compensation thing to it, but that's I do on Unity. Let's start doing the shooting first. I'm gonna shoot just directly from the character in a certain direction, and we'll see what happens. So I should do that. It doesn't matter. It could even be from the movement system. Honestly, I should add a different system for that. So because we don't need a lot of data for that, and we'll just make it run after these. So we'll call this shooting system. Basically, I need the entity, the transform of it. I need the player. And I need the character rotation because do I update the transform? No, I already have the rotation updated from the movement system correctly here based on the yaw, the simulation yaw. So I don't need this anymore. I just need this. So what I get is I get the input for the player. Then I have the character position and character rotation. I'm gonna use that to shoot raycast. Let me see if I have questions here. So no new questions. We have some people watching, but I hope you guys are understanding everything. So this is the shooting now. So let's compute the shooting direction and shooting. So shooting position will be the character position. Yeah, that's the center of the capsule, so that's okay. I'm gonna use that for now. So center. I'm not trying to be very accurate on a gun offset. That should be straightforward. So my point here is to do the lag compensation system. So first I need to know the layer. So layer mask will be layer mask dot. Oh, I thought I would have a create. No, it's layers. How do I get a layer mask? Oh, I guess no. This is the quantum layer mask. Don't I create a layer mask? I thought I had a. Oh, it's in the. Oh, okay. Thanks. F dot get layer mask. And then I pass the layer. So I want the layer mask to query only the lag compensation objects. Technically, we should get the layer mask using the, let's say, the environment and the lag compensation stuff. But what I have is I have that offset as part of the input. So the tick offset is gonna give me exactly the layer. So I have to cast this guy to int. It's a byte. It casts just fine to int. Oh, what is it? Sorry. What does get layer mask expect? Oh, it's an array of layers. Oh, a string layer. Yeah. Okay. Oh, it's an array of string layers. Can't I just... No, I want to have the layer mask by number. Well, I know how to do a layer mask, but can't we give... No, I don't want to check layer exists or not. I'm manually creating these layers. I'm sorry. I'll just do this myself. So this case is input dot tick offset. So it's the layer mask is going to be one shifted by this. So if tick offset is 0 is the first layer, is that the order? Is it so that the first one is that? I think it is. We will confirm that. Yeah, layer 0 is not the bit 32, is the first bit. Then layer 1 is the second bit and so on and so forth, coming in from right to left. Yeah. So we have the layer mask. So what we'll do here then is var hits equals, so let's get the position is position of the character, direction we have, yeah. So hits equals frame dot physics 3D dot raycast, not raycast all for now. Then we need the origin, which is filter dot... Oh, we need to do this only if the player is shooting, right? But we'll do it. So transform dot position. We need to get the direction. That would be... I'm not going to consider the pitch, right, for now. But as I said, we'll just shoot flat. But of course, we could do that later. So the direction would be transform forward. Transform forward. Layer mask. What else we need on the raycast? Oh, forward. Oh, I think we need to times the distance. I'm gonna do FB 100 or so. And we have the layer mask, and I think we need to have the query options. What are the default query options? var options equals query options dot hit all, hit dynamics, hit kinematics. Do we have a... I'll just get hit all and compute detailed info. So I'll do this, compute detailed info. So I'll pass in query options as well. After layer mask. Oh, that is distance. So direction is a direction. Then we pass distance. Then we pass layer mask. And then options. Yes, that's it. So we know what to hit. So this is our hits. I forgot to do this. So if input fire was pressed. Of course, if you have a machine gun that does with a cooldown, you're gonna do that, but I'm not gonna bother with that type of logic for now. This is just to demonstrate the lag compensation for now. So just checking for... If we have questions. No? All good? So let me check. Okay, so if hits dot has value, Is that it? It comes with a null if I don't have a value. Because this is one hit 3D because the raycast is not the raycast all. So it's not hits, it's hit. Okay. Then we have a shot. And what I'm going to do is I'm going to, in this case, I'm going to just do draw dot sphere at the point that we shot because I want to show that we will have this computed at the right position on every single frame because of the things I'm going to, both on the verified frame and on the prediction frame. So I'm going to show on one color with predicted frames, and I'm going to show then the registration coming with a different color when it is the verified tick. So we'll do this on, so va equals h equals hit dot value. So we have h dot point, so that's the position. Then we have a radius. For this, I'm gonna do radius, I think 0.5, it's too much. 0, I think 0.2 is good. Then we need a color. So color equals f dot verified. So if it's verified, we're gonna do at red color RGBA dot quantum, yeah, red. Otherwise, color RGBA blue. So the prediction is gonna use the blue color. The verification, when it happens, we use the red color, and they should be exactly the same. They should show exactly the same. So I want to comment on something here. So you see all this. This is a kind of quite a complex thing just to get like compensation and thing. But the cool thing about this is that this is actually very kind of game agnostic here. So we can, for example, this lag compensation component can be added to. So you see that the shooting does not know about lag compensation. It's just shooting at entities. Um, the lag compensation component can be added to any moving thing. You just make sure you do not predict that, and then you have snapshot interpolation on top. So the things combined with itself, but they're for shooters, but they're not specific to this shooter. So you can reuse this whole idea in whatever is the shooter you're doing. So it's a bit like the lag compensation system in Fusion, right? So you drag and drop this stuff, and you use the API. It works for you. So you add these systems, add these components to the entities, and that's it. So yeah, I wanted to comment that. Okay. So okay. So sorry, I saw a message from someone from the team. So so the shooting is done, and we have a debugger here, which is, so we just need to add this system called shooting system to our list, and we need to make sure we have the fire input with the mouse button. We don't have that yet. So let's do these two things. So first, the shooter local input. So we have the jump button. Let's add the fire button as well. So I dot fire equals unity engine dot input dot get mouse button 0. Current state of the mouse button. First time I press, that's a shot. So that's it. Then we need to add the system to the list of systems we're using. So that goes into our runtime config sample systems guy here. So I think I'll add this guy at the end. So I just need to add this guy as a shooting system. Save this thing. shall be working. Shall be working both online and offline. Let's see. Oh, I don't have anything to shoot at except myself, and I don't want to shoot at myself, but because should actually we're probably just not seeing it because we should be able to shoot at ourselves here. It's probably just inside the thing and we're not seeing, but let's not shoot at ourselves. Yeah, we need to create let's create a moving sphere kind of thing. So let's go back to the game. We can test that in the sample game as well. So we have this guy, blah, blah, blah. I'll just add a new quantum 3D sphere entity. I'm gonna call this guy the moving sphere. We're gonna make a little system to move it back and forth. But this guy needs to have a white moving sphere thing. Collider, sphere collider, it's here. Then we need to add to it the lag compensation, because it would be the lag compensated one. And then we need to add another one that we'll call, it will be another quantum 3D collider that we'll call the moving sphere hit entity. And this guy, the renderer, is gonna use the transparent green renderer we have, green material we have. The hit entity, it will not have the lag compensation. You would have the hitbox entity component to itself. This will be filled. They both need to be, I'll create them as prototypes here, but because we're just gonna add a bunch of the moving spheres, we don't need this one to be here, but this one needs to point to the moving sphere hitbox entity as its prototype. Bake this, and this shall be it, because as you will move around, it will have its positions registered. This is the beauty of it. So this is what I was talking about. So you create the entity, add the lag compensation component to it, which is kind of like a hitbox root kind of thing, and then you add the entity you want to be its hitbox, and you add a certain component to that, link the two, the systems do the rest. So now we need to create a system to move this sphere. So we'll create a tagging component so we know which spheres to move, and also to define the range. So I'll call it moving entity, and we'll just have an FP vector 3 original, yeah, original. Then I'll have FP vector 3 speed, velocity, have an initial velocity, and we'll have an FP max distance. Once we reach max distance, we invert velocity. So we invert the signal velocity, and we do that, and we keep doing that. So yeah. Moving entity, and now we need a system to do that. I'm gonna do this system on a separate file because I'm tired of using the same. So moving entity system. But let's copy some simple stuff. So I'm not using Unity. I don't need any collections, so this should all be good. I think I need to import photon deterministic. So this will be called moving entity. Moving entity system. We use the filter of moving entity system, and this filter needs a transform. And what is the name of the component? Moving entity. Need anything else? I don't need I don't need the lag compensation stuff. That's gonna be handled by the other system. So only thing I need here is I don't need any player link. I'll change the position based on the velocity. So position of this is gonna be is gonna add plus equals filter dot move dot velocity times f dot delta time. Then if the so var diff equals position. Oh, there's one thing I need. Minus filter dot move dot original. I have to initialize this original. I signal on component added for the component move entity. I have to use this to store the original position. Oh, do I know the transform position of this thing? I'll just do a hack for now. I should use the component materialized one. I'll just store if sky equals fault. Then I will use that to store the original one. So even if you start at the origin, it would just let it move one tick and then it uses that one as the origin. So it's okay. Then I do the diff here. So if diff dot magnitude is larger or equals, this is a bit safer than filter dot move dot max distance. Then I invert the velocity. Minus this. That's it. That's the movement system. I just have to fill the entity with that and it shall be good to go. So our moving sphere then needs, so see this, I need to add the moving entity thing and I need to set some stuff. So original is going to be filled in. So I'm moving it with 10 meters per second. That's already fast as damn. And max distance is going to be 10 meters. Let's see how that plays. Maybe 5. Maybe that's already too fast, but let's see how it goes. We can just test locally first. Oh, cannot see. Oh. Something like here should do. Not moving. Did I forget anything? Has a transform. Velocity has let's oh, as always, forgot to add the system. So sample system, add moving entity system. Let's see now. Yeah, here's our sphere. It's so fast I cannot see anything. Huh? I think I should draw the ray as well. So let's take a look at that. So this is movement. So the shooting system. Draw dots. Maybe I'm not running in debug mode. Is debug or release mode? I think the editor always runs debug, right? I should have the draw line, ray, position, direction. Yeah, this time the direction needs the multiplier. To be the multiplier here. Then I need it to have a color. I'm gonna make this guy enter. See which of my colleagues are still watching who can help me on this. Checking if we have any questions. No new questions. Okay. Let's see if this thing is actually shooting. Not sure. Or maybe my... Did I add the shooting system? Yeah, I have the shooting system in here, but let's see if the input is having the... Oh, it's a local one. Yeah, shooting input is doing. Yeah, I need some help, but let's see what's going on here. I think it's just that I'm not running debug. So, which is good to learn a bit here. So config, bake, window, code gen, toggle, debug. Yeah. Oh. Yeah, so it was on release. So let's switch to debug here. Yeah, I am poly input. Actually, I just checked on the state inspector. I do have the input for that. I think it's just that I was not running debug. I was running release. I need to run debug to be able to see these debug drawings. So it should. I think everything is already working. Well, I still do not see any rays, but I can log some data if I want to. Should I do debug all platforms? Is that it? So what question, what answers I have here? Okay. Yeah, I need to restart Unity in this case. So let's do that. That's a bit annoying. So, but yeah, but that's what it is. So we have to. One other thing I could do is I could change the color of the entity that was hit for a few seconds. I don't want to do that. just gonna restart Unity. I had an issue with my Unity Hub installation, so I have to open Unity manually at the moment. Mm, okay, so should have worked, right? But I'll try to log. I'll log to see if it's actually going. So I'll try to log here, log.info, info, shooting. That should do it. Let's see what we get here now. Yeah, it is shooting. Why isn't my debug drawing showing up? Do I have to enable the gizmo somewhere now? Well, I can show which entity I hit and compare with the position that we have the main entity at. So, and we can do that on the verified frame and on the predicted frame, for example. That would be an interesting way to do it because, yeah, exactly. On the predicted one, yeah, uh, thinking here. And that's all correct. Okay, so the guys are checking why it was not doing that. So what I'm gonna log here is if I have a hit, I'm gonna log the position of the hit entity. So hit transform equals, so I'll get the main position of the entity. What was the position of the entity itself, not the hit position itself. So frame dot get, I know this thing would have a transform. So transform 3D, it must have a transform 3D, and it will be hit dot value. Oh, it's our H thing here. Saves a bit of code. H dot entity, so that's the entity that was hit, the transform of it, and I can also get the main entity, the main entity that could be the hitbox component because we're querying with a layer. So it's called hit, what is the name of the component again? Hitbox entity. We get this dot main entity, and then we get the main transform of this entity to see which one we hit. So main transform is the transform of the main entity. And then what we do is we shooting hit, we'll call it hit entity at, then we do the hit transform dot position plus your current should be plus main transform dot transform dot position. And I also want to log verified or not, so we know how we are computing that. So plus frame dot is verified. See what shows in this case. Let's see if this is working. Okay. I think there's a problem with the layers. That's gotta be it. So let's take a look at what other layers we're using. So all these hitbox entity layers, they have physics collider, and they're using 1 to 8 as layer. And when I'm shooting with the layer mask. Maybe my layer mask is wrong. Let me ask this question to the guys here. Daniel, if you're watching this, so okay. So thanks Juan for the gizmo tip. We're gonna use that, but I also need to check why my layers are not working. I think it could be that this tick offset shift here is wrong. So should be the right layer mask here. So am I using the right order here? So raycast direction distance layer mask. So I can try to shoot all layer masks and see which one I hit, but now I wanna maybe um, what is the difference between these all? Hit all, hit triggers, dynamics, kinematics, and stuff. Yeah, okay. It does everything. So it should be working. Why isn't this working? Daniel, if you're listening, I saw you saying waving hello. So I'm setting the layers correctly on the colliders as an integer number between 1 and 8. And I'm creating a layer mask manually from a number that could be 1 to something by doing a shift on the number 1. So I'm just shifting that left. Is that correct as a layer mask? I think it is. So let me see if I have an answer. Not yet. So, okay, let's enable gizmos and see what we get here. So, uh, so what kind of gizmos we're talking about here that shall need to be enabled? Gizmos enabled. Oh, yeah, they were not enabled. I had them in the scene, so... Well, I still... Oh, yeah, I got the raycast now. But I'm still not getting the hits. And I should get at least one hit at some point. Oh! I think it's just that I'm not... Maybe it's just too high. What is the position of my entity? Should it be hitting the middle of those spheres? I think I can just make those spheres bigger. So let's get the other sphere. Just make these things much bigger. Yeah, got it. So that one we got. So moving sphere itself. Let's make this thing. So where is the quantum collider? Is this affected by the it is. So if I change the scale, it does already. So I'll just do that here as well. These things are gonna be hugely big, but that may help if it's just a matter of badly positioned rays, because I'm not looking at, I don't have a camera set up yet, so sorry. Maybe it's just that. No, I'm still not hitting anything. I'm not hitting even the regular sphere, so that's what is weird to me. Even the white one. Notice one thing though. Um, Let me see. I think there's something off here because I also see multiple white ones. I should see only the green ones, right? Oh no, that's just the collider gizmos. I can delete that. Yeah, okay. So, oh, I have some stuff to read, sorry. Okay, so no, I'm not shooting from the floor. I think my entity itself. Oh, well, let me take a look at how. Oh, but that's just the. Well, I can just check the entity itself. So position 1.5. Oh, so it's not super low. State inspector. That's my character. So what is the transform? 1.5. How big is this sphere then? No. Well, it is at 1.5, which is exactly where my ray is shooting at. Yeah, let's try what Daniel is suggesting. So I'll remove the layer mask just as an attempt. So we just pass all -1. See if we get any hit in this case, or if I'm just missing something else. Let's run again. Yeah. Yeah, I'm hitting at the main entity. But the layer mask was giving a problem as well, yeah. One thing I can do is I can to avoid this error is I can remove the collider. Can I make this collider disabled? I cannot, but I can remove it. I don't need a collider on the main entity in this case here, because I'm trying to shoot only at the light compensated version of them. Let's see. Okay, the light compensated ones are not being injected into the physics engine, I guess. Hmm. So my suspicion is on the other system then. So I think we can put back the layer mask here. Have the layer mask back. So the injection system. Oh, that's it. So every time I add one, in every tick, if added is smaller than this, I had a protection to not inject inject colliders on the first 8 frames, which was kind of stupid. And I forgot to add this how many are already valid to be used. I forgot to add this line here. So basically, all these colliders are being injected disabled. Or yeah, so they're all being injected disabled. That was the problem. Okay, let me see what the guys are saying. Yeah, they are being injected before the physics update, Daniel. So I paid attention to that. So the system setup, I'll show again the order of where the systems run, but it shall work correctly now. Oh, now I made a mistake somewhere, and my character is totally off. And I'm hitting them, yeah. But why isn't my character moving down? Oh, it is. What? What is off here? No, it's not. Gravity is not working. Um, and I want to fix something else. System, sample system. So the sequence is culling, light compensation injection, then movement. Oh, oh, where's the physics system? Oh, it's here, sorry. Here's the physics 3D. So light compensation injection, physics 3D, um, movements, light compensation update, which should go for the next frame, shooting system, moving entity system. Yeah. So the shooting all happens based on what was injected before. So, but why isn't my character coming down anymore? Ah, I see why. No. Huh? Did I click on something that broke? My gravity is not working. Trying to run this guy online. I have no idea why the gravity stopped working here. Shouldn't have. I have an idea though. Well, this is the character controller. It's all done in C sharp, right? But in any case, I'm gonna I'm gonna disable the native physics engine. So physics. I'll disable the native physics just in case, just to see if it's nothing wrong. I don't think it could be this. Why is my character? Oh, I know. I'm stepping on top of my own. I'm trapped inside the capsules of my own other entities. I have to query. Okay. So I have to ignore the lag compensated stuff for my own character controller. That was yeah, yeah, Juan got it right. So I'm colliding, yeah, I'm colliding with my own. I wonder why that did not show up before. Um I think I never tried to jump and now yeah, I know what. Hmm. So I can fix that totally on my move. I think my character controller itself can yeah, layer mask. I can just get default, which is 0. I think that's gonna ignore the yes. That's gonna ignore all the lag compensation things. Okay, finally. Okay, I don't have any lag here, so I have to hit very... This thing is moving fast. It's difficult to change. Let me see what is the... So we're running at 30. Maybe I should run a bit slower. That's gonna make the lag compensation be much further back. Yeah. But I have to hit at what I see, and because I'm running locally, I have to look at the white one actually at the moment. So if I make them move slower, I'm not gonna demonstrate really well. But the point is, let's take a look at the log here, what it shows. So we hit it at position 0.99999, and it is already at tick 0, so we're hitting it at 1 tick behind, which is expected. We're exactly 1 tick behind. So was on the verified frame. But funny, we're not hitting on the predicted frames, I guess. Oh, maybe I'm not injecting. Oh yeah, I'm only running this system on the verified frame. Am I? What is the how did I decide for that in the end? So this one, which is the injection, it always runs. So I always inject my past positions. What I'm not gonna do is I'm gonna move the thing only on the verified frame. That's one thing I can do to simulate what I need here. Then this one should not run on prediction, which is the update system. Yeah, this one does not run on prediction. That's correct. So this one, maybe that was the problem. So I have to, if f dot is verified equals false, return. I don't store new positions except when I have the verified frames. And the other thing I have to do is I can make my moving entity system also run only on verified frames. To simulate, I mean, it will be jittery, but it will simulate me seeing things in the past and being able to hit them still correctly and deterministically. And I think that's going to be the last thing before I go to eat something. But I'll go back to this to polish. I'll do some stuff off camera, and we'll go back to the last points, which is snapshot interpolation and doing a few more things. But let's test this better. So this thing is running only on verified frames now, I guess. And we should be able to hit on the white stuff. So how far? It's the same. So one difference. And let's try this online now because we're going to be a bit more behind. So we should see a little bit bigger difference of what we hit. So essentially we're going to be, when we're going to finish the snapshot interpolation, we're going to be looking much further behind, but the hits are still going to happen based on what I see because what I see is behind, but it is fine. So the white, so yeah, it's cool now because the white thing is very jittery. We don't have yet the snapshot interpolation system going. So it is jittery. We have to fix this by actually implementing the snapshot interpolation itself. But the point is, damn, I cannot make this thing look forward. I need to have this thing looking forward. So let's try again. Okay, it's looking forward, centered. So I have to try to hit at the white thing, and what I'm seeing is in the past because I'm seeing the verified frames, but I'll still hit because even though this is in the past, if I can synchronize with the white one, yeah, I got it. So, and I am still hitting it because I get the, so how big is the difference here? Interesting. Because it doesn't matter, I'm compensating for how far back I'm seeing things here by looking at the verified frame. But I have to, yeah, so I got it. And the interesting thing is that if you guys saw, my raycasts actually happened both on predicted and verified frames. So if you see here, on the prediction, I hit the entity one frame behind what was the verified frame. And when the verified frame came, it used that same difference to the verified one, and it actually hit at the exact same position. So we confirmed the hit on the verified frame by looking at an offset entity. So I lost my alignment again. Oh, that's gonna work now. Bang. So we have another example here. So again, the positions match bit by bit perfectly on the prediction, the local prediction, and on the verified frame, which is cool. And I'm running, oh, I think my stats is not showing the right prediction and resimulated frames number, unfortunately. But I think there is a cool way to see that, which is I can just see the number I'm sending on my input. So this looks at the this is the offset I'm sending. So sometimes I'm 1 behind, sometimes I'm 3 behind. So let's try to hit again. Hit again. And this was, oh, interesting. This they had a difference between the verified and the prediction, which is interesting. But it did still hit. Try again. Another one. Again with a small diff. I wonder why. Oh, now it matches perfectly. Again. It's matching perfectly, and the difference between what I shot at and what I saw. No, it's actually always matching. I was looking at the wrong stuff. So it's this and this they are matching. So whenever I shoot at the white one, I get the same values top and bottom. That means that they're matching on the prediction and on the verified ones. Yes. So this is all working. So let's go back to the topics list. I forgot where I think it's always here. Yeah. So we've done the ring buffer for the lag compensation. We inject the collider at the right moment. We do an optimization for the sequence of masks. I process raycast only again. Although this is the next optimization. I'll still do this one. So this part here is done, which is the lag compensated raycast. So we're missing still organize the whole prediction of movement and not prediction of movements, and doing the snapshot interpolation for anything that's moving on verified frames only, which could be moving things or AI or remote other player characters. But let's finish this still by doing this one here, which is this extra super cool optimization of we don't need to have the masks for every single. We don't need to have to inject every single collider in the engine. We can check the ones that are needed based on is there a shot to be done or not at which tick. So what we'll do here is we'll check over all the players. We'll do a system for that. So it's on the lag compensation injection system. We're gonna have one before it. So we'll have a very simple public unsafe class. Lag compensation culling, input culling system. And it will be a system main thread, a regular system main thread. No need for filtering because we're not going to be filtering entities. We'll just add a regular update. And what we'll do here is we'll loop through the players. So for int I equals 0, int I is smaller than f dot player count plus plus. I'll check the input for each player. I'll have a mask. So I need to add a mask to global. So global I need to have an int 32 shoot mask. So we'll flag the tick offsets that we need to inject. So, and we will compute this by scanning the inputs of all players very quickly and checking if they have the fire button pressed. So we get input equals f.get player input I. Then if input fire was pressed, or is pressed, whatever, because you might, depending on the type of weapon you have, but in this case we're only shooting when you press, so I'm going to do this. So I'll first reset the mask, so f global dot shoot mask equals 0. I'm going to reset it here, and what I'm going to do is I'm going to logic or the input dot tick offset, it's one shifted by this, because that is the layer mask of the distance I'm interested in. So if my layer mask matches one of the shooting masks, I will inject them. Otherwise, I will not. So that's essentially it. And we'll see that it will not inject the light compensation hitboxes into physics engine unless they are needed. So that's basically what this would do. So this is ready in terms of creating the mask. Now on the injection system, we have this thing here that decides if it should be enabled or not. So another thing we do is we enable it here, but we can do also a check with the mask, which is we have the layer. So va layer mask equals 1 shifted by the layer. And then we check if layer mask or f.globals.shooting mask. So this has to be different than 0. So it has to match the bit. So if the bit exists in the shooting masks, then I enable this. Or, well, I have enabled it already. What I do is, if it's equal 0, I disable it. I don't bother to inject this collider if there is nobody shooting at this timing. So this is super cheap to do and avoids injecting, I don't know, as many characters as you have, multiply by the number of light compensation hits. So if normally people would be shooting at a specific range, not too much. So I would say that in worst case, you're always avoiding at least half the light compensated hitboxes to be in the physics engine. So it's always worth it. To test that if this is working, we need to look at, we can take a look at the collider list on one of the entities. So let's take a look at it could be my own character because I also have the light compensated thing. So we can take a look at the transforms because they're going to be small enough that we can open maybe all of them and see them all in one screen. So we see, oh, I don't have the enabled state here. Sorry about that. Yeah, maybe, okay. I think one thing I can do is I can disable the renderer of the prototype. the moving sphere prototype, because then we can see only its gizmos and the collider gizmos. So we will not see the gizmo unless it is necessary. So let's play. So I have a lot of messages here, but okay, not related. All good. Whoa, a lot of verified frames. Oh, actually, it's still showing all of the gizmos. So it's not showing them as disabled or enabled. So that's a shame. I think we'll have to check that later. Oh, no, I know why. I didn't add the system, right? Of course. I always make this mistake. So sample system. I have to run this one before the physics. I'm gonna replace the culling 2D by it because it has to be before the like compensation injection system. We're also not gonna use the default culling 3D system, but we'll do a different one to predict the local character, not everything else, and so on. But what we'll do here is inject the light compensation input culling system in here. But funny, my mask should be 0, so I should be making all the colliders disabled. Is that color the disabled one then? Maybe that's it. Um, uh, so it is working here, but I'm not sure the disabling of the colliders is correct. Because I still see all the gizmos. I'm not sure. The hits are still working, but I'm not sure about the color. I don't know if Daniel is still watching, so because the color of the gizmos do not look correct to me. I would expect disabled colliders to have a different color. So let me see. Quantum. Oh, we have now a specific gizmo setting. So dynamic collider, static collider, kinematic character control assets collider, disabled collider color. Why are they all looking disabled? So I don't know. It should be showing red, green for the ones enabled, but they're all looking disabled now. But it looks like it's working correctly on the logic. So I think it's correct. Yeah, maybe it's just that the collider that we see, the green one is so close to the main that we don't notice. And these are just the disabled ones. But my own colliders are all green, so that looks strange to me. Why my own character collider is green? Oh, okay, that's the render. That's not the. So let's think. So we can try to run this much slower. We can try to run this at 5 frames per second. So we see very sparse. Yes. I don't see them green at all. Can try to see. Oh, I know why. It's because the click is only for one tick, so we don't have enough time to see it because then it's already predicted and we don't see it anymore. Okay. Yeah, it is. It shall be working. I'll have a way to debug this better. So, um, I'll show here with a log because essentially we should be hitting enabled false for most of them, and I'll add an info here when we actually uh, added collider, and this will happen for a single frame. So this will happen for a single frame only, but of course with prediction. So we'll see it a few times on online, but it's difficult to see because it will be only once and then it's over because it's only on the tick at which I press the button. So, but we should see, it should not be logging anything because nothing is being added. Oh, that's why then. I made a mistake in the logic. What is the mistake I made here? Maybe the shoot mask. Start with the shoot mask 0. Tick offset I'm sending. Oh, yeah, but only if fire was pressed. I don't have this, my shoot mask. I should be able to see the shoot mask. Let's take a look at the shoot mask. It's the last thing. Running globals. Shoot mask. Yeah. If I click fast, I see. It's the second bit when I have it. I have it as the second bit, but normally it's mostly 0. That's correct. So the shooting mask is being computed correctly. Then what I do here is I check. Why is this not being 0? It should be 0 all the time because I'm not shooting. What is the mistake I'm making here? This one's being logged. So it should be mutually exclusive. Okay, I'm doing some. So this is never happening. Yeah, I'm getting a bit tired. I don't know why this is not working here. So this one should be disabling and it's actually never hitting this. So the layer is the hitbox layer, which is the one that came, which is a number, not a zero. So this is not a zero. Or it's. Oh, damn it. That's why. I wonder why nobody noticed this. It was an and, not an or. An or, it is here to add. And I need to check with an and. That was it. To check if the bit is set or not, we use an and. I was using an or. Of course, it's always going to be a valid number. So what's going now is we're not adding the colliders at all until we shoot. So if there is a shooting, we add a collider. If there is shooting, we add a collider both for the my collider and the collider of the other entity. But we only do that if there is shooting. And interesting, it may be that I'm sending a zero offset tick when I'm running here, so I have to treat for the case zero. And so it's because when I'm sending tick zero, I should also allow it. Interesting. So it's not gonna happen as zero ever when playing online, so I will not bother with that. Saving this sample. Let's try online and then it should be stable now. Quick play. So I have a lot of colliders that are. I have a lot of disabled colliders and yeah, so I add the colliders on a certain tick. It's difficult to hit with the jittery frame, but I got it. So I added the collider on the tick. I hit it on the verified frame and on the false. So I added them on the predicted tick 200, 205. Then when it's the verified version, I also add them and I confirm. So I'm running only one tick ahead here, it looks like, in this case. Let's clear this whole thing. I did not hit. No hit. I need a hit. Not easy to hit. I have to add the snapshot interpolation for this to be possible to hit actually. Oh, oh, I should run this at a proper frame rate. Not at 5. Because the things are too sparse. So this is the last test before we stop here. Okay, so we got this on frame verified, once on non-verified, another one non-verified. Yeah, so we simulated 2 times with prediction, the same frame. In both we hit on 0.66. Actually, the second prediction was corrected and it hit here. And then we hit on the final version that matches the last prediction hit. That's all good. So for this to be super smooth, we need to add the snapshot interpolation, and that's what I'm gonna do next. But of course, not now. Um, we showed a lot of stuff already. I hope you guys enjoyed this. So this video is stored for future references, and I'm gonna work off camera on this to clean up a lot of the things, add the snapshot interpolation part. So let's just review here what is the complete idea. So we have done the camera inputs, not the first person camera, but actually the snappy mouse YAL. We did the lag compensated raycast, the whole thing, which is this long list of things here, including this last optimization here. It's also done and done. So the lag comp stuff is very far. So next, just adding proper snapshot interpolation for the objects that are not predicted and predicting only the local character. This thing here is very easy. This one here, it's a bit involved. We'll do it on the view side. And that's it. So as I said, hope you guys enjoyed, and see you guys next time. Bye.